In this video series, we're going to be focusing on describing computer organization and microprocessor. The steps we're going to go through is first introduce a general concept that is used in design or implementing a microprocessor system and a computer, and then we're going to try to come up with the explicit or exact implementation that we can do in the lab or you can do in the lab on your own. And as the three tools we're going to use for the practical side of this thing are Mplab X, PICkits, and the some microcontroller. In our case, we've decided that we're going to use this microcontroller. And notice I'm referring to this thing as a microcontroller, not a micro processor. So a microcontroller basically is a microprocessor, so it has the CPU. It usually has some memory also, all built into the chip, plus a bunch of other functionality. For example, this one will have an A to D converter, will have a pulse width modulator, it will have a UART in it, and many other things. Will have timers in it. These are the timers and all the kinds of stuff in it, and that's why they call it, instead of calling it a microprocessor, because it has all the other function, we refer to it as a microcontroller, because in a sense is a computer on a chip. Okay. And the particular version we are using in this for the rest of these video series is PIC18F 1220. Okay, and we're going to spend in a little while, we'll spend some time looking at the specs for it. The other thing we are using is this development environment. This allows us to write programs in C or assembly language. Assembly is closer to the hardware, and that's kind of what we are trying to understand right now, is how you build a system from grounds up. Even though this capability is available, we will not use it. We're going to focus primarily on the assembly sides of it. This is a Mplab is an IDE, is an interactive development environment, which allows you to write the program, to assemble it, to simulate it, and then also use it to program the chip in here. And the way you program the chip, we have, depending on which one you end up, we have PICkit3 and PICkit2, and both of them work just equally well. You've got the connection with the PC or with your computer is through a USB connection or through a cable to your computer. Then you download your programs into one of these devices, and then they have a 6-pin connector here. And in your lab kits, you could find some angled connectors so you can connect it to your board. And then these 6 pins are connected to appropriate pins on the processor, and you just say, once you have assembled the program, you say program this device, and it automatically programs the chip. After that, you basically have a working microcontroller, which you can have it to do whatever it is that you want it to do for you. This is our attempt here is to be at the high level. The rest of the videos in here will go in much more detail about how to use each one of these specifically, but here we want to give you a concept of kind of what are the big pieces that you need to use to get your job done of designing this system. So let's go ahead and start by looking at this microcontroller, PIC18F 1220. And the best place, or one of the places you can find a data sheet on this one, is go to engrcs.com in here and click on the component specification, and about halfway down or all the way on the bottom of the page, in my computer at least, you will see that there's a data sheet. Now, it's not recommended you download this data sheet. It's well over 300 pages. It's best to use it in the form of a reference if you're looking for something, okay? and it's got a very good, and you can search for different things and all of that. Now, as you noticed, much like all the other digital stuff, the data sheets are combined. When the two parts are very similar to each other, they're going to put them on the same data sheet, and they make distinctions of this is 1220, that's 1320. And so you've got to be careful when you read the spec to make sure it applies to the part you're using. Remember, in our case, we are using 1220, so we got to just pay attention to that. Okay? So if you look at this device, let's just take some highlights of this device. One of the highlights is it comes in 18 pin, 20 pin, or 28 pin, depending on what we want to use it. If you look at it, this device is very designed for very low power and very conscious use of power, so you can have this thing run, idle, or sleep, and each one of those would use a different power levels. And then there's got a whole bunch. It's got an internal oscillator, so you don't have to have an external clock. It works internally. It can run at all kinds of speeds depending on what you want to do. For most of our work, we're going to run it with the internal timer, which is when we're going to run it at 32 kilohertz, which is the slowest speed you can run it at because it's easier for us to monitor it. Here's a little table which tells you what's the difference between 1220 and 1320. As you can see, our 1220 has only 4K of RAM, not a lot of RAM. The 1320 has a little bit more, double the size, and on and on. So those are some of the differences. The rest of the stuff, you got 16 input-output port for both of them. The rest of the stuff is the same. The only difference is the amount of memory. That's why they kept them in the same data sheet. Okay. It's got a bunch of peripherals. It's got 3 external interrupts, which we're going to learn what happens. It's got a pulse width modulation. It's able to control other motors and things of that nature, increasing power, decreasing power. It's got enhanced UART, so USART, it can accept serial data and put it into parallel format. You can give it parallel data, it turns it into a serial data. So, and then we don't want to go into too much detail, but that's pretty much this device is a CPU plus a bunch of other functionality. Now, packaging, this device comes in many different kind of packages depending on what your needs are. We're going to focus on using the 18 pin 1220 for what we are doing it. It's got a surface mount version, and it's got another version with more pins for folks who need more precision or a different format. Okay, that's a SSOP. We're going to use DIP because it's easier with our hands to put it in, take it out of our proto board. If I was doing manufacturing and wanted to build a whole mess of them, I would probably either use the SSOP, which is for our QFN package, which are flat package, and it's easier to install. Okay, and then the rest of this document has every detail you ever wanted to know about this in order to use it in your design in the pages. And the best way again to use it is search for the particular item you want, or go through and look at the sections that you're interested on the site as a PDF. Okay, so that's a data sheet. PIC 1220 is what we're going to use throughout the document. Sometime instead of calling it PIC 1220, you might see us refer to this as PICmicro. And PICmicro is a general term used to just describe this type of architecture. One of the things I really should mention that we are using 1220, but let's say you learn this, but you decide that you want to have a different, you want to have different functionality, or you want to have a lot more memory, or whatever else you need. Microchip has literally hundreds of different types of products that you can go search based on how much memory you want, how many I/O ports you want, and all of that. So if you go here, you will go to the microcontrollers and microprocessor. You can select the 8-bit, 16-bit, 32 bits, and all of these, and they got tons of it. You can and they have a really nice searching mechanism to find a particular processor you want. All of these are pretty similar in architecture, so whatever we talk about 1220 would apply to them as well. So that's a good place to go. Now, let's go ahead and take a look at Mplab. These devices we really don't have to know much about them other than USB connects to Mplab, and they program your device through the 6-pin connected to the appropriate pins in here. So let's go ahead and take a look at Mplab. And Mplab, you can download it from Microchip site. The latest version is fine, works beautifully, and let's go ahead and you start it up. And here I've started one up. The screen kind of looks like this, where you put your code. Here is where your code goes, and later on we'll talk about the various aspects of writing assembly code in a little while. As you can kind of see already, semicolon indicates comments, pound defined for the constants, and then codes do write. And these are assembly language, which we'll talk in more detail later. The structure of files are that there's going to be some header files if you create one and other things, but your source file, I called it main.sm, goes in here, and then libraries and loadables. This is an IDE in the sense that I can compile things by going and clicking on some of these. There's a little hammer and a broom. I'm not sure if you can see it because the screen icons are so small, but you click on this one, it compiles it, and as it's compiling, it gives you a bunch of messages here. Anytime you see a red or a blue, pay attention, because that means there's a warning or an error, so you gotta go correct it. The download and programs, once you have the PICkits connected, you click on this, items, and go and do that. Now, we have lab number 1, which is you're welcome to, after this video, to go do that, because that one here in this video I've talked about the overall pieces and how they hook to each other, but in that one lab it walks you step by step of it has an existing program that you copy and paste in there. You get to assemble it, you get to simulate it, you get to download it and program your chip, and you get to build a little circuit around it so you can see what is going on. I would highly recommend that in terms of learning the how this whole process works. So getting back to this, so we've got Mplab, which is the environment we're going to write our code. We've got this PICkit. We've got 2 versions of it. You can use either one of them. That has a 6-pin that gets connected to your device, to program. Let me go ahead and take a minute and let's take a look at lab number 1, where is a more of a detailed view of the detailed steps to develop solutions. So let's go ahead and take a look at that and see if we can do a kind of a quick overview of that. So the lab 1, let me kind of start from the top. It basically starts by kind of giving you a link of where you can download if you want your own version of Mplab. I believe, yes, Mplab is available for Windows, for Linux, and all that. So you can download your very own version of it if you would like to run on one of your own PC. Otherwise, we have some available on the lab computers as well. And then it walks you through step by step how to create a project, how to copy the code, how to name a file, how to assemble the code, and here it gives you a sample code. So because we haven't really talked about how to write an assembly code, you take a sample code here, you plug it in, write the simulation, run it, all that, and then what we'll do, and then programming. When it comes to programming, here is your PICkit 2. If you remember, there was pin 1 through 6, and this is the pins on the 18F 1220, the chip, which you connect when you want to program it. And again, we have a right angle pin there. That's probably the best thing to use it instead of individually wiring it. This way you can take the device, take the PICkit out and let your system run on its own. Let's see. And then here gives you an example of a circuit you can build to see if your program is running well. This is U2 is your 1220. This is a 5.5 timers, which you probably know how to build from earlier videos. And then you got a bunch of LEDs, and you watch what this does. And then that's it. So that's basically, I would highly recommend after watching this video to go off and try to implement the lab number 1, just to put all of the pieces together, and actually doing it step by step is the best way to integrate all that information together. That brings us to the end of this particular video, where we have just introduced at the high level what an Mplab is, what's a PICkit, and what is a PICmicro, in particularly 18F 1220. So the rest of this set of videos will assume you know how to do this. You've gone through lab 1, and then we're going to start introducing the features of this processor. We're going to introduce how the assembly code and the various aspects of writing assembly code, converting it to machine code, and hopefully building some useful devices.